We'll discuss test for population correlation. This test is useful for bivariate data. There are two tests in the test for population correlation. One test is related with single sample and in which we have to test the hypothesis that rho equal to rho naught. Whereas the another test is based on two independent random samples and the null hypothesis for this test is rho 1 equal to rho 2. So in this test, rho stands for population correlation coefficient and R stands for the sample correlation coefficient. Dear student, you know that in all this testing procedure, we are using 4 steps. The one step is related with the setup of the null hypothesis. So that means we have to set up this null hypothesis. The second step is related with finding the test statistic. The third step is related with the critical region and the fourth step is related with the conclusion part. So that means every test procedure having these 4 steps. So today we are discussing this test for population correlation and the first test is related with test to test if the population correlation coefficient in the population has specified value h naught rho equal to rho naught, and in this case our h naught is rho equal to rho naught. So that is the null hypothesis part. So the given sample has been drawn from a bivariate normal population with correlation coefficient rho, and Professor Fisher has proved that. So this is the test statistic for this population correlation test. So u is equal to z minus I divided by square root of 1 upon n minus 1. So this follows a normal distribution with mean 0 and variance 1. So what about this z? So z is nothing but, so this part is, see this highlighted part, so that stands for z. So z is equal to 1 upon 2 log e 1 plus r upon 1 minus r, and xi is nothing but this part. So that is nothing but 1 upon 2 log e 1 plus rho divided by 1 minus rho, and this z follows normal with mean xi and variance 1 upon n minus 3, and we need to take the test statistic as u. So u is equal to z minus xi divided by, so this, see this is my u, so z minus xi divided by square root of 1 upon n minus 3, which follows normal 0 1, and find out this value of u. So we can call this as a calculated u. The critical region, you know the critical region. So table u can be obtained such that for two-tailed alternative, probability of u is this probability of u is greater than or equal to u alpha by 2 equal to alpha, and calculate the table calculated u and table u. So suppose if the value of calculated u is less than table u, then we can say accept the null hypothesis, otherwise we are rejecting the null hypothesis. Friends, the second test is related with to test if the two independent sample correlation coefficients differ significantly. So our h naught in this case becomes rho 1 equal to rho 2. Rho stands for population correlation coefficient. So that is my population correlation coefficient. Rho 1 is nothing but the first population correlation coefficient. Rho 2 is the second population correlation coefficient. Suppose we want to test if two independent random sample of sizes n1 and n2 and correlation coefficient r1 and r2 respectively have been drawn from same bivariate normal population or from different normal population with same correlation coefficient. So in this case, what we have to set up our null hypothesis? Our null hypothesis is rho 1 equal to rho 2. That is, the sample correlations do not differ significantly. What about my Z statistic? So the statistic value is this. So Z1 minus Z2 divided by square root of 1 upon N1 minus 3 plus 1 upon N2 minus 3, which follows normal 0, 1. And what is this Z1 and Z2? See, the value of Z1 is equal to 1 upon 2 log E, 1 plus R1 upon 1 minus R1, and Z2 is nothing but 1 upon 2 log E, 1 plus R2 upon 1 minus R2, where R1 and R2 are the sample correlation coefficients. And again, we need to calculate this value. So calculated Z. So check this value with the table value of Z. If calculated value is less than table value, so we need to accept the null hypothesis. Otherwise, we have to reject the null hypothesis. So this is the test procedure for bivariate case. That means in which we are interested in testing whether my sample correlation coefficient is actually reflecting in the population correlation coefficient. And these are the test procedure. These are the two tests, and we have discussed these two test procedure with the help of sample observations. So thank you very much.